Hello everybody, welcome to the webinar today. Good morning, good afternoon, good evening, depending on where in the world you are. My name is David Copey. I'm in the information strategy team at MongoDB. I also have on the line Matt Keep, who's my colleague in Director of Product and Market Analysis in our UK office. And we'll be hosting this webinar today and addressing any questions that you may have. So thanks for joining. The topic is blockchain, also referred to as distributed ledger technology. As a quick background, most people have probably heard of blockchain in the context of Bitcoin, which was released in 2009, world's largest digital currency, as a global sort of alternative to fiat currencies like the dollar, the yuan, the euro, etc. It's had great success, got a lot of attention, and we could probably host a completely separate webinar on Bitcoin generally. But the focus today really is moving on to the technology that enabled Bitcoin, which is the blockchain. Just for a second, just to level set everybody, what is blockchain and what is so special about it? It's really a decentralized database, right? So as opposed to a database that's hosted by one organization and managed by that one organization, blockchain is a methodology of decentralizing the storage of data across multiple organizations and in a peer-to-peer fashion, so that control of it is owned by multiple members. And each member can enter transactions into that ecosystem and validate those transactions. So it's a way of sharing that ledger type concept across multiple organizations, with that state being distributed across every member of that network. Another key attribute of it is that unlike typical databases, which you can update, remove, delete, and insert to, the blockchain database is immutable, as in once a transaction is accepted and entered on the blockchain, it cannot be changed. The only way to change the status of something on the blockchain is to enter a subsequent transaction that updates the state of that asset. Through advanced cryptography, that also renders this setup tamper-proof, so that if something in the history is changed, that change is immediately evident to all the other participants on the blockchain. Okay? So what this allows is, underpinning Bitcoin, for example, it's enabling the trusted transfer of assets, whether that asset is a cryptocurrency such as Bitcoin or Ethereum, to more assets more generally. So whether that's an item in a supply chain, whether it's intellectual property of some variety, precious metal, diamonds, etc. It's really setting up a mechanism that multiple parties in an ecosystem can share transactions in a trusted way. Okay? So when we look at a blockchain application, we find it's very useful to think in terms of the software stack for this application. Right? So at the top, obviously, is the actual business application that's supporting the business process, fixing the business problem that's looking to be addressed. Whether that's in financial services, which is typically what a lot of blockchain use cases are referred to in, but certainly not solely in financial services, potentially in the supply chain area, identity management, etc. And the first thing to note about this, as you'll see that we'll dig into in the next couple of slides, is the fact that we're separating out what would typically be considered a blockchain into a couple of layers, the blockchain layer and the database layer. Right? And it's important to do that because as organizations look to deliver real enterprise blockchain applications, the bottom line is blockchain is a database. Right? It's storing data in a very unique way and with very unique attributes, but it's a database. Right? So as vendors look to build blockchain solutions, system integrators build solutions, organizations, etc., There's a couple of alternatives there. They can, in addition to building the blockchain logic that we'll get into in a second, they could look to build the database portion of it as well, the persistence layer. Okay? But that's not a trivial task. Building an enterprise class database is difficult, and it's not something that's directly related to the core mission of building a blockchain solution. So what we've seen a lot of is organizations such as R3 with the Corda platform, BigChainDB, etc., have chosen an established distributed database as that core persistence layer, and then engineer the blockchain characteristics around that or on top of that, depending on how you look at it. So that if we look at that in a little more detail here, the blockchain layer, what that's really bringing is the decentralization aspect, that there's no single entity controlling this database. There's every entity has an administrative role in maintaining it, and the blockchain layer provides that coordination and the protocols associated with enabling that to happen. The immutability, the fact that you can't go in and do an update on a record and change it once a record is in the database. It is defined and immutable and cannot be updated per se. And also instantiating this concept of asset transfer. So obviously in the case of Bitcoin or Ethereum, that's a cryptocurrency that if I own a Bitcoin and I use it to purchase something, that Bitcoin is transferred to somebody else. But looking at more broader use cases, that could be an item in a supply chain. If I manufacture a widget that is then moved to the next entity in the supply chain, that's an asset that's transferred to somebody else. And maybe in reverse, there's a payment of some variety that's transferred from that subsequent step to me as a compensation for taking part in that step of the supply chain. So there's this general concept of an asset and it being transferred between parties on the blockchain. So these are all the core capabilities that a blockchain or distributed ledger application bring. But when you look at especially an enterprise adoption, in an enterprise production adoption of this type of application, that data that's being instantiated on the blockchain needs to be stored in the database that we mentioned earlier. So what are some of the key attributes of that database? Well, working from the right-hand side, that database tier needs to be enterprise hardened, and by hardened we don't just mean security patched, etc. from a security perspective, but it needs to have the appropriate tooling around it for backup recovery, for monitoring, capacity planning, etc. It's not just a database that sits there. It's going to become a key part of an enterprise ecosystem. Scalability and data distribution are extremely important to a blockchain application because it's an ever-growing list of records. As we mentioned, there's no update. You merely append an additional transaction to the database to reflect activity. So having a database layer that's scalable in all aspects and remaining performant in that sense as the database grows is critical here. From a query perspective, if we sort of fast forward a year or two to where most analysts think that enterprise adoption of the blockchain applications will be in production, as we've said a couple of times, the blockchain is a database, and as such, it will be storing data that's a part of a broader business process. Okay? And in that sense, that data is valuable for analytics, for business intelligence, for operational reporting. So it's very important that the database persistence layer of a blockchain application has the ability to serve that data in a very queryable and performant fashion, right? Because if data is being stored in a blockchain, I may want to know, what is the profitability of somebody that I'm doing business with through a distributed ledger where data is stored within that blockchain application. What is the sort of the direction of business with a particular business partner? Is it increasing? Is it decreasing? How rapidly is a supply chain working? Are there slowdowns within the supply chain? There's real operational questions that need to be asked of this data that's going to be locked in the blockchain. So you need to be able to get to it. Okay? And that's over and above. It's essentially just like any other database. It just has these additional attributes that we discussed on the previous slide around decentralization, immutability, and assets being instantiated within it. Okay? So, from our perspective at MongoDB, what we just described on the previous slide aligns perfectly with MongoDB as an operational database that we're seeing in the market today, and that has driven a lot of our adoption and growth. So I won't talk through all of the attributes here, but essentially anyone who's familiar with MongoDB knows that we're extremely scalable and stay performant at scale into the hundreds or tens of thousands of transactions per second, handling data in many terabytes, petabyte scale, and so on, in an always on, always available fashion, which obviously is critical for a potentially global application such as a blockchain. The ability to flexibly model different data constructs is extremely important with a blockchain because in the case of Bitcoin, it's relatively straightforward that the blockchain is storing transactions related to Bitcoin. Who spent what coins with in what transactions and what is their remaining balance, etc. But a lot of the promise of blockchain in broader usages is around this concept of smart contract, so of modeling the assets that we spoke to a couple of slides ago. And MongoDB's JSON structure is ideal for that because it's a very flexible way of modeling different data shapes and constructs within the database. And obviously the ability, as we said on the previous slide, around queryability and being able to operationally report and do analytics around the data stored in the database is extremely important. So having that flexibility in a flexible query language and the ability to manage indexing to ensure that those querying capabilities stay performant over time is very important as well. So that's really where we see Mongo fitting. It's a great alignment between the core capabilities of the platform and what you really need in that persistence layer underneath a blockchain application or distributed ledger application. Okay? So bringing that all together, really just in a graphical format, essentially the benefits of a blockchain or distributed ledger are moving from the left-hand side, where you have a central entity that's considered the single source of truth for the ledger, where multiple business partners, rather than interacting directly with each other, trust one central entity to do that reconciliation of those business interactions, to the distributed and decentralized architecture on the right. The benefits of that, the system on the left has been in place for many decades, so it's functional, it's fit for purpose. But the challenge is it introduces delays because everybody now has to go through that centralized entity. It's potentially a single point of failure. So if that central entity has a system issue, if there's a security breach, that can be problematic for everybody. And also by being a single point, there's additional costs that you're introducing to the system in terms of maybe additional infrastructure, transaction fees, etc. And by having to interact with a central entity, it introduces delays into the process. And that's really the beauty of blockchain, is that by bringing the attributes and the protocols of a blockchain distributed ledger into this equation, each of the four entities that are doing business can now have their own copy of the ledger. They don't have to wait for a centralized entity to reconcile all the transactions, which speeds up processes, and obviously time equals money, so there's cost savings there. It potentially eliminates a lot of infrastructure and transaction costs, etc. And it enables more direct interaction between those entities. And just in terms of use cases, as we mentioned, blockchain is very often referred to in a financial services use case, because that's the sort of the genesis of this in terms of Bitcoin, and there's many, many use cases in financial services. But if we just pause for a second and look at the diagram on the right, and if we look at the four entities that are doing business, if we imagine that one of them's a hospital, one of them's a clinic, one of them's a doctor, and one of them's a pharmacy, we can see that there's use cases of this far outside purely financial services in terms of shared medical records. In terms of, if these four entities are part of a complex supply chain, there's a lot of value to be had from sharing that information between each entity on the supply chain. You look at some of the things that Walmart is doing around food provenance, tracking items, whether it's food products or other items through a complex supply chain, is extremely important for maintaining that consistent view of where that entity is and where delays might be, and so on. Okay? So any business scenario where multiple entities are interacting with each other and there's value to sharing data around those interactions is a perfect usage for a blockchain or distributed ledger. We've listed a few sort of general examples here. You can probably all think of particular types of use cases that would be useful. This is really the crux of why blockchain has such a huge focus in the industry at the moment, is the potential of uses for it, and the savings and operational benefits and cost reductions that it can bring are absolutely huge. Okay? So with that, one of the things that at MongoDB we like to bring into the equation here is what about enterprise adoption of a blockchain? Okay, so most people on the call are probably familiar with the CAP theorem around distributed systems, the consistency, availability, and resiliency to network partitioning. And there's a very similar concept that we can apply here. Trent McConaughey, the CTO of BigChainDB, published a white paper that gets into this in a lot of detail, and it's called the DCS triangle. Right. So if we take a second just to talk about that, the three dimensions we look at here are consistency, obviously the same as in the CAP theorem. Do all nodes see the same data at the same time? Scalability, and in this case, we're using the term planetary scale, where can a system scale to the throughput of a large global enterprise transactional system? Okay, and how decentralized is it? Okay, there's a large spectrum between the centralized model of one entity controls a system to the fully decentralized model of something like a Bitcoin or an Ethereum. Okay, and where on that spectrum does this system need to fall? Okay, and as with the CAP theorem, you essentially get to choose two of these and do them well, and the third sort of has to be secondary. Okay, so the different use cases of blockchain really fall differently, and these three dimensions are prioritized differently depending on the specifics of the use case. If you think about a Bitcoin and Ethereum, the priority for those systems is consistency, obviously. We're talking about a cryptocurrency, so consistency is absolutely critical for ensuring there's no double spend of a currency. And they're fully decentralized. Anybody can start up a new node, join it, and become essentially an equal member of the network. Okay? So for cryptocurrencies, those two are the priority. Unfortunately, because of the nature of the triangle we're looking at here, those choices do have an impact on scalability. So if you're familiar with Bitcoin, the number of transactions per second that it can support and the confirmation time for new transactions on the Bitcoin network are relatively small. And while they work fairly well for Bitcoin as it stands at the moment, again, if we're looking at large, complex enterprise scale systems, that sort of throughput and performance is really not going to cut it. So what we really see if we're looking at an enterprise blockchain deployment, which is to be used in large international global organizations, we really have to pivot our priorities on this triangle and look more. Consistency clearly is still very important, but scalability is a very critical aspect here. Being able to do 7 to 10 transactions a second, which is sort of the ballpark of a Bitcoin, that's really not going to cut it with a large organization. So we tend to see organizations prioritizing the scalability aspect of this over the decentralization, okay? Which makes sense, because if you're talking about a complex enterprise use case with multiple business partners interacting, the ability of literally anybody on the planet to fire up a new node and join the network, that really doesn't make sense in an enterprise use case. So making that trade-off is okay. So that's some of the considerations that we generally see when we're talking with organizations around how are they going to adopt a blockchain-like application. Okay? And to a certain extent, there's a maturity model that is really interesting to think about, because most of the analysts are saying that widespread production adoption of distributed ledger blockchain technology is several years away. What that means, I guess we'll all find out over the course of the next few years. I think there's one Gartner slide that says 5 to 10 years before everybody has a blockchain. Okay, so that's a really long time in technology terms. So what we generally try to look at is, okay, so there's going to be a point in the future where the technology and the vendors in the space and the solutions that make sense for folks have matured, as technology generally does. But what are the things that organizations need to be doing in the interim to move towards that type of technology? Okay? So if we look down in the bottom left here, really you're ultimately looking to use a distributed ledger, a blockchain, as a solution for a business problem. Right? There's something that's either not working well, that you want to do more efficiently, that you want to take cost out of. So let's identify what that is. Is it trading in a financial services organization? Is it a foreign exchange process? Is it a supply chain use case? What is that business process? And as a sort of initial phase of that, what we also see is generally a lot of organizations actually have multiple internal ledgers. There's not actually one single ledger for an organization. There's multiple systems that store some of this transactional information. So making a jump from that, from essentially a multi-ledger scenario to a full production distributed ledger, that's extremely difficult. Okay? So what we generally see is organizations are have strategic initiatives around strategically managing their data, both in terms of transactional data with third parties, but also their own internal operational data, and looking to unify that information and have a much more structured and almost channelized view of the data within their realm. Okay? So this leads to that maturity of, hey, I have many systems right now, each with their own database. I'm moving to a more sort of data fabric type environment, looking at an operational data layer that's giving me a consistent way of managing the transactional and non-transactional data. And then once you've made that step and you've got a much more rational way of managing data, then subsets of that data will lend themselves to incorporation into a distributed ledger. So for instance, if I'm trading with a business partner, the details of that trade make sense to share on a distributed ledger. What did I sell? How much did I sell it for? When did I sell it? What was the settlement date, et cetera, et cetera. Okay? But there's other aspects of that business process that should not go on a distributed ledger. For instance, counterparty risk. What is my internal assessment of this person I'm doing business with, and should I even be doing business with this person or this entity? That you're not going to share that publicly, right? So with any business process, some pieces of data will lend themselves to a distributed ledger, some will not. Okay? And by following this type of maturity curve, you're preparing the organization to get efficiency benefits out of that process, but also preparing for a distributed ledger implementation. And the bottom line is there are business benefits and significant savings to be had from the first few steps on this maturity curve, before even really necessarily implementing distributed ledger. So we can help organizations with this preparation and with assessing where distributed ledgers can fit within their organizations as the technology matures and develops. Okay. Another way, in some ways, to look at that is if you consider on the left-hand side is sort of the typical current centralized system where applications run on a centralized processing tier, whether that's a local server or cloud-based, EC2, Azure, Google, etc. And then data is stored across a file system and a database such as MongoDB. That's the fully centralized model. The future vision of a fully decentralized ecosystem is where you have fully decentralized processing, such as an Ethereum or Hyperledger. The file system itself can be decentralized into an IPFS or something akin to that. And the database has been decentralized through adding blockchain characteristics to MongoDB as the underlying data store. And what we really see for the next couple of years at least is the majority of use cases where an organization will adopt distributed ledger technology fall somewhere in the middle. That there's going to be, as you mentioned, a business process, a function that has some data that will make sense on a distributed ledger, but other data that should not, and should stay in a traditional centralized database such as MongoDB. So by working with key partners in the industry, what we're doing is building that blockchain type capability built on top of MongoDB, but then also being that traditional database as well. So that way, it's a consistent way of storing data, reporting against that data, where you're just adding in those blockchain and distributed ledger characteristics to the data points and the data segments where it makes sense. Okay. The other way to then dig into this is, well, how are organizations going to adopt a blockchain solution or platform? And the way we look to break this out really is from a deployment scenario. Is this system going to be deployed within an enterprise, so within the four walls of an organization, or is it going to be deployed between multiple disparate business partners, using the term consortium generically in that sense? And then is the data stored within the blockchain operational, where clients and consumers of the data access the blockchain data directly, or is there an intermediary database in the way? Okay, so breaking things down into those sort of four categories, the deployment patterns change quite significantly here. So this first example, the enterprise deployment pattern, where this blockchain database is deployed within an organization, a lot of folks are probably thinking, well, wait a minute, I thought a blockchain is supposed to be decentralized, so it's not one organization that's managing this database, it's multiple. I thought that was the whole point. And that's a totally accurate perspective. However, there are scenarios where, especially when you get into large international organizations, where you could almost consider different geolocations, different business units, different business functions within, even if they're under the same corporate umbrella, they can be viewed as different entities. And when you look at the complex systems that a lot of organizations run, that organization can actually reap benefits by leveraging this type of solution to break down and simplify some of their own internal operational processes. Right? So while it doesn't align with that true decentralization of multiple independent entities running nodes, there's still business value to be had by looking at this type of distributed and decentralized model within an organization. So in the case on the left, there's potentially clients accessing the blockchain data directly, and then external clients accessing it directly as well. So, for instance, a foreign exchange type use case where there's multiple geographic entities that are involved in touching a transaction that's recorded on the ledger, and external auditors are able to now view this ledger and greatly simplify compliance processes. So that would be an example of the type of configuration shown on the left. And the bottom line is there's business value to be gained from doing that, and that's ultimately what we're all in the game for, is to deliver value to organizations. An iteration of that is if that core transactional data that's stored within the blockchain is not directly accessed, then an operational data layer can be implemented to expose that to the consuming clients. Okay, so considerations there will maybe be a supply chain, maybe there's additional permissioning that needs to be introduced to limit what each of those clients can see. And the reality is there are performance characteristics of a blockchain involved with the generating of the cryptography needed to generate new blocks, etc., where a client may not need to be exposed to those potentially performance delays, and hence an operational data layer is a lot more performant way of exposing that data to internal and external clients. The evolution of that is if we move to what folks typically think of as a blockchain where it's separate entities, we're really just extending that model where different organizations now have a truly decentralized copy of this database with separate administrators within different organizations. So this is more of a traditional model. But that same distinction between operational data and non-operational data can be applied as well. It's where an organization using the model on the right is still getting the efficiency gains of leveraging a blockchain distributed ledger across multiple organizations, but it may not be appropriate to expose that data directly to clients. The operational data layer built on MongoDB can really help simplify that. And this also becomes more important when you're talking about separate organizations, because clearly their privacy is more important, may even be mandated in financial and healthcare type use cases where certain organizations cannot be allowed to see all of the data. And there may be permissioning associated with that, where different entities can do different things with the data. Maybe only a subset of clients can generate new transactions, but other clients can view the full history, etc. Some of those more complex use cases can be reflected in one or more of these, one or both of these scenarios. Okay, so those are some more complex deployment patterns. The bottom line, really, just to sort of wrap up the presentation portion of this, is when we look at, there's a lot of research, there's a lot of piloting and experimenting going on with blockchain. What we're really focusing on is what is that enterprise adoption of this technology going to look like, and bringing it back to that sort of software stack type perspective. Is we really think MongoDB is that ideal database underneath the blockchain logic that's providing that operationalization, the scalability and performance, and the ability to still query that data just like any other data within any other database. Okay? And then when you factor in the additional blockchain capabilities of decentralization, immutability, and the rendering and transfer of assets within the blockchain, you really get that combination of characteristics that we think organizations will need as these solutions mature and start to become adopted. Okay. So that's really the bulk of the content that we wanted to walk through today. I do see some questions out on the chat. So Matt, I'm not sure if you've had a chance to look over some of those, and if we have any specific items we want to circle back on?
So yeah, a couple of questions around the blockchain software above MongoDB, and a couple of questions around whether a company like BigChain, who we mentioned a bit earlier, competes with MongoDB. That's come up quite a few times. One of the key things to point out is that BigChain DB actually uses MongoDB under the covers. So, MongoDB is providing, as I think we set out very early on in the slides, MongoDB is providing persistence of the blockchain data, the distributed ledger, but the properties of the blockchain itself are around immutability, around decentralized control or partially decentralized in enterprise applications, around things like asset transfer through multi-signature authorization, or whether it's the execution of smart contracts, is actually handled at the blockchain level above. MongoDB is not providing those capabilities. What MongoDB is doing is working in conjunction with a blockchain software layer, BigChain DB being an example, and it's really the persistence layer. BigChain is able to take advantage of blockchain software generally, is able to take advantage of MongoDB's rich querying and very flexible document model, but the core blockchain characteristics of decentralization, of immutability, of asset transfer are handled by that blockchain software and not by MongoDB. So I think that's just an important distinction to make, and I think that addresses a number of the questions that have come in.
Right. Yeah. Thanks, man. It's really a complementary, as you're showing on this screen. The blockchain is a database, but it has certain characteristics that make it unique, and those are kind of complementary to the capabilities that MongoDB provides.
Another question around whether MongoDB is storing the metadata, so maybe the hashes, for example, of the various blockchain transactions, or the blockchain data itself. And the reality is it can be either. It can be configured in either way. When we look at some of the permissioned ledgers, distributed ledgers that are available, that they provide multiple modes of operation. Some of them use a file system just to store blockchain data. Some of them use a regular commercial off-the-shelf database to store the blockchain data itself, or maybe just store metadata around transactions in the database that can be queried, and then that data can be extracted appropriately from the persistence layer. So it can either store the blocks and the transactions of blocks natively within the database, natively within MongoDB, or it can store metadata relating to them. It's configurable either way.
Yeah, and I think the point that the blockchain database is another database that stores potentially operational data, so that analytics, business intelligence reporting. If we're putting if there's transactional data and data associated with trading with business partners stored within the blockchain, that's critical information to incorporate into an operational reporting scenario. So it's important to be able to incorporate that into click reports, Tableau reports, etc. So having that data itself stored, the specifics of the transaction stored within MongoDB gives you that ability. You can just store the metadata, but then if you're locking the core transactional data off in a file system or in a different data store, that then just makes that reporting scenario a little more complex. So the specifics, I think I saw a comment earlier today on the blockchain topic, and I think folks are saying that the number of articles you see on blockchain is actually starting to decrease, and that maybe that's an indication of more and more organizations are starting to build solutions, and we're sort of a little bit past that Gartner hype cycle phase, where folks are really getting into, okay, what does this actually mean? What is the solution that we're actually going to be able to deliver? And we're seeing more engineering around delivering those solutions, which is obviously a great thing. And ultimately, a lot of these questions come down to, well, it depends on the use case. We always hate to answer a question with, well, it depends, but in many cases, that really actually is the best answer. It really depends on the specifics of what is the use case, what is the industry, what is the purpose of this solution, what are you looking to accomplish, etc. And that really drives a lot of those types of decisions. And I think there's a question here about is it mature enough to be used in an industry like healthcare and and so on. I think that's to what we said earlier. Most of the analysts predict that we're probably several years away from mainstream production adoption of blockchain, and I use those words very specifically: production adoption, not a pilot or a test, and mainstream as in the majority of organizations have some sort of blockchain, right? So I think there's going to be an evolution of adoption here as all of these types of questions are worked out. I think there is a question in what you find in most scenarios when folks are talking about a blockchain solution, and healthcare is no different, is yes, it's a good fit. The concept of having an immutable record of my personal healthcare history, so that if I walk into a pharmacy to refill a prescription, refill a recurring prescription, that pharmacy has access to see that I had a surgery that involved taking blood thinners several months ago, and there might be an interaction between that drug that I never even thought about I needed to refill and the thing that happened in my medical history previously. There's a lot of benefit to be gained from something like that. But clearly with healthcare, there's huge privacy concerns, and permissioning at the permissioned ledger, the permissioned blockchain becomes much more important. So I think a lot of the work that's going on now between all the different folks that are looking at this, whether it's IBM and Hyperledger or BigchainDB or some of the big SIs are looking at building practices around blockchain. That's where those questions are going to be answered. So I don't think there's necessarily a solution that's empirically mature enough right now. But I think that's where the industry really is working out how do we adapt to this technology to real world use cases where there are real world implications of storing this information in a decentralized ledger. I think there's a question around where would finality be placed in the triangle. I think finality to me is also almost an iteration of consistency, if I'm interpreting that correctly. That finality in terms of the completion of a transaction is really an implication of the consistency that if I'm looking to execute a transaction on the blockchain, am I seeing the most current version of that, avoiding double spend, etc. So that would be my take on that. Apologies if I misunderstood the question. So the question around, can you please elaborate on streamlining back office processes and the financial services? So I think that's ultimately really almost I hesitate to say the sweet spot of blockchain, but a lot of the interest in blockchain is in that process. That if I look at if I execute a trade in my 401k or something, it takes 3 days to settle, and for the most part, that is purely and simply because there is a centralized reconciliation process that needs to happen, and taking that time, expense, and delay out of the process is what blockchain promises to bring. So where there are processes that involve multiple entities interacting, either in a programmatic or certainly in a manual way, blockchain can really expedite that because it blends the ability to write to your own local copy and read from your own local copy of the ledger without in a trusted fashion. So I've sometimes heard it described as it's almost like a register in your checkbook. I'm not sure anybody uses those anymore, but in a checkbook you have the register where you go in and balance all your transactions. I almost envision the blockchain as it's a way of everybody that you do business with, sort of your electric company just writes into that ledger on your checkbook when they've received your payment and cashed your check for your payment. But what blockchain brings is, well, you don't want to open that ledger up to the world so that anybody with a pen can start writing transaction with it. Blockchain brings the advanced cryptography that essentially it's almost like a pen with a fingerprint reader on it, so that only authorized people can actually register transactions in that ledger. That's sort of how I envision it in some ways, and think how easy it would be if when you're looking to do that financial reconciliation, that it was all consolidated in that fashion. A question around, does blockchain support ACID properties? I think that's an interesting question in terms of, I think yes, the blockchain distributed ledger does satisfy some of those properties. I think, again, it gets to the consistency, scale, and decentralization priorities of the system. There are scenarios even with Bitcoin where you can have multiple chains, and then if the blockchain underneath Bitcoin forks for whatever reason, because it's a large network of transactions constantly occurring, you can actually then end up in a scenario where one of the forks will die and be consolidated back into the other. So in that sense, that pretty much fails the ACID test. But the transactional delay, I believe there's protocols around how many blocks you should wait for. I think it's wait for 6 transactional blocks to be generated before essentially a transaction is confirmed. So I think in terms of a traditional transactional system, which I think is the genesis of the question, it probably fails a couple of those tests. But I think there are sort of protocols around how to manage that. Matt, I'm not sure if you have any thoughts on that topic.
No, I think you covered it.
I think a great question here around seeing as blockchain maturity is still a few years away, is MongoDB looking at building a modified version which does enable immutability? I think that's really what it's exactly what we're working on, is how partnering with key players in the industry to build and deliver that type of solution, and what does that look like, and what does that mean? I don't think the industry, quite honestly, is at a point where we know necessarily what that needs to look like in all its detail. But that's really the focus of our alignment and who we're partnering with to build that out. So I think just to wrap it up here, there is, as a follow-on, I believe you'll receive a recording of the presentation today, of the webinar, a copy of the presentation we ran through. And there's a couple of references I'd like to just leave up here. We do have a white paper, Building Enterprise-Grade Blockchain Databases with MongoDB. That's an excellent read. Covers the things we've talked about today in a lot more detail. And I think we'll hopefully address a lot of the other questions that you may have. There's also a link here for our information strategy team at MongoDB works on things like blockchain and other strategic transformational initiatives at organizations where MongoDB can play a significant part. So we'd be happy to connect with anybody who has questions or has real-world use cases that they're working on. I think, as I mentioned, the blockchain topic and industry and technology is at a point where we all need to figure out where it goes next. So we're actively looking to engage with folks on what do you see blockchain bringing to your organization, and get as many perspectives as we can so that we can align to delivering value-add solutions for the marketplace. Okay. So thanks again, everybody, for your time, and look forward to hearing from folks, and have a great day.